Hi folks, today we'll witness aviation history in the making. So stay tuned for this exciting story.
You could bank to the left a little bit, yes.
On December 17, 1903, Wilbur and Orville Wright made their first flight at Kitty Hawk, North Carolina, with their powered aircraft. Today, April 14, 2021, with Rick Hayes as his witness, Dennis Carley will make his first flight at Sun and Fun in Lakeland, Florida, with his electric-powered Aerolite 103 aircraft. As Dennis taxis for position, he gets the go-ahead for takeoff from the air boss. During this early morning flight, Dennis is following the Ultralight Aircraft flight pattern and sharing the airspace with powered parachutes here at Paradise City. He climbs at 500 feet per minute to reach pattern altitude. During his downwind leg, he reduces power, which greatly helps my camera stability. Although he completed multiple loops of the pattern, my video is only a sample of one loop of this pattern. Turning base and final for a smooth landing. As Dennis completes his flight, he waves to John Moody, hailed as the father of ultralights. Okay, this is Dennis Carley after his first, maiden flight here at Sun and Fun. So I'm going to let Dennis tell you what he felt.
Yeah, thanks, Wayne. Well, this is the first time we've flown the electric propulsion system here at Sun and Fun. We've been developing this for about a little over a year. This is the second plane we've put a propulsion system on. This is the third incarnation of the propulsion system itself, and we've got it refined now to where it's operating exactly like we want it to operate. The video you shot right there this morning is pretty indicative of how it flies and the speeds and the climb rate and so on. We're quite happy with it. We're probably going to fly it again a few more times here this week at Sun and Fun as well.
Thank you very much, Dennis. Appreciate it.
All right, thank you.
Okay, hi folks. We're here at Sun and Fun, the new Sun and Fun after being shut down a while. And I have with me Dennis Carley, the Aerolite 103 expert. And he's going to tell us all about this brand new electrified Aerolite. Dennis?
Yep. Good morning, Wayne. Well, we brought this airplane out here this year. We've been working on this project for about 15 months or so. What we have here behind us, this incarnation of it is basically the third version of what we've done with the electric propulsion system. So we've made lots of tweaks and changes to the propulsion system over that last year, a little over a year. Now we finally got it to the point where it is operating the way that we want. We've got enough duration out of there for it to be viable for the average ultralight pilot to go out and fly it in the mornings or fly it in the evenings and have enough battery life to enjoy it. And we've flown it yesterday. We flew it again this morning, and lots of interest and lots of curiosity and lots of questions about it. So we're happy to have it here and happy to let people finally get to take a look at it.
Now I know that this is, like you say, you've done it through a few iterations now. When do you expect this to be available now for people to actually purchase and fly?
Yeah, it's actually available. We've sold a few up here already at the show this week, and we've had lots of interest. We've had a lot of our current owners have stopped by and seen it and inquired about converting their existing Aerolite to this propulsion system, which is they are able to do. So, yeah, we're lots and lots of interest, I guess, is the best way to put it.
Well, I think the beauty of the Aerolite airplane, I mean, you have an Aerolite 103, and if the weight meets that requirement, it's a 103 airplane. You also can put other engines, other weights on it, and it's a light sport airplane.
Yeah.
So, and the beauty, I think, is you've got an airplane that is robust enough to make those kind of transitions, airframe-wise and flight characteristics.
Yeah, that's exactly right. I mean, we have an airplane that if you want to build it and fly it as an ultralight with gasoline or electric, you can do that. If you want to certificate it and as experimental, you can do that as well. And we have one electric propulsion system, but we have the capability to offer that with 2, 3, or 4 batteries in that system. And if you want to start with 2 batteries in the system, when that aircraft is put together, it is wired for 4. The tray will hold 4. So if you want to increase that at some point in the future, you can add a 3rd or a 4th battery and just extend that flying time. And gasoline engines, let's see, Wayne, we've got 5 gasoline engine options. So there's something out there for pretty much everybody's needs.
And now you offer this airplane as well as your other Aerolites in kit form as well as completely built.
Yep,
right?
yep. And it's about our orders are about 50-50, and most of the guys that we build a ready-to-fly airplane for, if they had the time or they had the space, I think they would do it themselves. But life is in the way, and they can't do it, so they ask us to put it together for them. Our build time is one of the lowest in the industry. You can take our kit. The average guy can put it together in 40 or 50 hours, and if he reads the manual, it'll look good, it'll fly right. So it's very, very simple to do. We have a lot of guys that have never put an airplane together before. They put it together, and they're quite happy with what they've gotten at the end of that. A lot of our owners, the vast majority of our owners are pilots, even though you don't technically have to have a pilot's license to fly the aircraft. And a lot of those owners are they're older pilots, and they still have a medical, but they reach a point where their flying is no longer the type of flying what it was 20 years ago. They want to go up in the morning, they want to fly for a half hour and have fun. They want as little government involvement in that as possible, and any Part 103 airplane meets that. The first question we always get asked is, how long will it fly on a full set of batteries? And my answer to that question is always, tell me how you're going to fly it, and I can plug a time into that for you. And I'll explain that a little bit because it's sometimes a little confusing. But we basically have a system that if you have 4 batteries in it and you climb up at a normal climb rate to a cruising altitude of say 1,000 feet, and you level off, you reduce the power back to an economical cruise setting. In our case, it's about 45 miles an hour. That will give you about an hour's worth of flying time. Now the flip side of that coin, if you say, I want to go out and practice takeoff and landing this morning, so you're going to do continuous climbs up to pattern altitude, and you're going to land, and you're going to taxi back, and you're going to do it again, you're going to cut that duration in half, because the consumption of that battery power is disproportionately high during those high power setting climbs. There's usually a happy mix in between there for the average guy. Most guys that have an ultralight that have owned it for a little while, they don't do takeoff and landing practice. They already know how to take off. They already know how to land. They want to go out and buzz around. So the duration of that flight is an hour, up to an hour. If you are the average guy like me, you have to go to work or something after you fly in the morning, you're going to fly for 30 minutes or 40 minutes, and you're going to put the plane back in the hangar and go on about your daily business. One thing too, I guess the second question that we get asked is, how long does it take to charge it back up?
Yes.
And each battery comes with its own 110 volt charger. If you take a battery that is depleted down to its minimum voltage, meaning it's reached a point where you can't use it to fly anymore, it's not completely dead, but it's down low enough that it needs to be recharged. A single battery on a single charger will take about between 4 and 5 hours to charge that back up to full capacity. One of the great things about this system, the way we put it in there, is when you have the batteries in the aircraft, whether it be 2, 3, or 4, and the harness is connected to those batteries, you can take an AC charger, plug it into one of those batteries, and that charger will then bring all of those batteries up to full power. It takes 4 times as long if you have one battery charger on 4 batteries as if you have each one. To put that into perspective, I flew the airplane yesterday morning for about 25 minutes here in the country. 3 batteries in the airplane, brought it back over here about, probably 4:30 in the afternoon. I brought one charger out, I plugged it into the one battery, we turned the charger on, and 3.5 hours later, all 3 of those batteries were back up to full power. So that's 25 minutes worth of flying, and if I would have put one battery on each charger, and that would have been an hour and 10 minutes back to full capacity. So if you want to fly in the morning, charge your batteries back up, fly again in the afternoon or evening, you can easily do that.
Now, the technology of the batteries, what are they? There must be a polymer type of battery.
Yeah, it's a lithium battery cell, and those we've got one over on the bench. You can take some video of it, but they are made with Samsung lithium cells. They are built basically on a skeleton frame. They're all wired together, and then once that is all wired, there's a polymer port in there that basically pots the whole thing together. So when it's done, everything is encased in that. There's one waterproof connector on the top. Everything else is completely waterproof. It's shockproof in the sense that there's nothing bouncing around on the inside, and you'll see it over there. It's a very tough polymer, and it is got a handle on the top of it. You want to walk over to the airplane and pull it out, you can pull it out, take it in, and charge it.
Now, the batteries themselves, we talk about the cells and how the cells and the batteries are built. But the batteries themselves, these 1, 2, 3, they're tied in parallel, is that right? And,
Yep.
And that's how you get the charging of all of them on.
Yeah, it's all tied together with the harness. So each battery at the top of it has a plug for the harness, and you plug that in, and it's everything is connected, whether that be 2, 3, or 4. You don't get any more power adding battery number 3 or battery number 4. You get longer durations.
You've got more amps to be able to pump in. Now, talk to me about the motor. Now, that motor is pretty cute.
Yeah,
I like that.
Yeah, we get a lot of people walk up to that motor, and it's small. It weighs less than 30 pounds on the mount, and people look at that and say, "Oh my gosh, you get enough power out of that to make this thing fly?" Thrust output, it equates to about what we get out of something in the 30 to 40 horsepower range. And there's a formula for, you can take the electrical component of this and convert it to horsepower, but that doesn't necessarily convert to thrust output at that horsepower. I'm 220 pounds. I can put, the way we've got this configured now and the way we have this current prop pitched, I get 6,700 feet per minute climb rate out of it, and it'll zip right along in level flight at full throttle. It's really works like we want it to work.
And I noticed the prop that you have on it. You have a 3-bladed prop.
Yep.
And so therefore you can ground adjustable.
Yep.
And you could probably set it for cruise and for takeoffs and stuff like that. Tell us a little bit about that system.
Yeah, so we've tried a few different props. All of them have been adjustable pitch props to this point, 2 and 3 blade. And like everything in aviation, if I gain something over here, someplace over here, I gave something up. There's no getting around it. So we basically, in the programming of the controller, and the adjustment of the prop pitch, and the number of blades, and the diameter, we basically find a point where we have a thrust output that gives us the climb that we want, and that still gives us the economy we want in cruise to maximize the battery life. Now you can tweak that a little bit, but most of that is programming for any given prop. So basically, when we send that system out of here's your propulsion system, you're using this prop, it's programmed for that prop. Put it on there, plug it in, it's going to perform like you want it to perform.
You got them matched. You got them.
Yeah. And we've got a wood prop being made for us now, a couple of different wood props to try. A lot of guys like the look of the wood prop on an ultralight airplane.
I know that Culver prop.
Yeah, Culver is wonderful propeller. Yeah, we've never had a better wooden propeller than Culver prop, and so I'm sure by the time we get up to Oshkosh, we'll probably have a wood prop on this airplane.
Okay, so that takes care of the power system, the propulsion unit.
Yep.
Now, is that kind of contained in one system? That power doesn't go anywhere else to change flaps or anything like that on radios. You've got a separate battery.
Yeah, that's right. So it only, the lithium batteries that are in the system only control the propulsion system. If you want our batteries on our flap system, our aircraft is always controlled by two 9-volt batteries anyways. If you want to run a portable radio or GPS, they always have batteries built into them. You can put we have a 12-volt lithium starter battery that we use that you can put on the aircraft. It weighs about 3 pounds. That'll run your GPS for about 2 days. And you can charge that up again if you want to do that. Most of that stuff, those small handheld electronics, that battery technology's come far enough that those will run for as long as you're going to fly anyway, so you don't really need extra. Well, another question we get asked from the guys that are kit builders is, well, how long is it going to take me to put that on the airplane when I get it? And it is incredibly quick to install, because it's basically, you hear the term plug and play. You hear that all the time, but that's literally plug and play. I mean, you put the engine mount up there. That takes about 10 minutes to get the engine mounted. You mount the controller, and you plug in the cables, you plug in the throttle, and you're ready to go. The system is ready to turn the key on, and it'll provide power.
Well, what I also noticed is you still have your ballistic parachute just up above the battery, so there's no change there.
Really, Wayne, we changed on the fuselage. The battery tray is supported by a couple of existing tubes in the fuselage structure. We didn't add any tubes. We changed the attachment points, and we changed the wall thicknesses of those tubes to support that extra weight. But if you walk up to this fuselage without the battery tray in there and look at it, other than seeing perhaps you see the wall thickness change, it looks exactly the same as every other one.
I mean, we talk about things that you don't need anymore. The gas tank, right? And there's the battery tray, the starter motor for the gas engine. Now, it must be interesting with respect to the throttling and the power controls. So maybe that's something getting used to, or is it pretty much?
Well, we designed it so it's a lever similar to a throttle lever, and it moves forward. It's got about the same range of travel as the gasoline, so we did that intentionally so it felt the same.
Sure.
Now it operates differently because it's electronic, and it's nice and smooth. There's no tension with the springs and the carburetors and whatever, but instinctively it's exactly the same as if you're using a gasoline powered engine.
I noticed when you flew, and I took some video when you flew, that you couldn't hear you taxi. I kind of looked for you. And then when you got ready to take off, I could hear the prop.
Yeah.
And the prop made the traditional noise of any other prop.
Yeah.
But it seems like it was still quiet. Quiet prop.
It is. Well, it is quiet. It's much quieter. It's the only airplane I've ever been able to fly where I didn't have to have earplugs or headsets on. And the electric motor itself makes minimal noise. A propeller is always going to make noise, and most folks don't realize how much noise the prop actually makes because it's being overshadowed by the two-stroke engines. But when you hear it, even if you hear it, it's making noise obviously, but when you hear that fly by or you're underneath it, the noise coming from this airplane is probably, a third or a quarter of everything else flying over.
Now, as far as RPM, judging where I should be when I'm landing or taking off, you have how does that work? Do you have a gauge
Well, it does, but there's an RPM indicator for the motor, and it's a direct drive motor, so there's no reduction drive. So if it's saying 1700 RPMs, then that's what the motor's turning. In a gas motor, if it's saying 2000, your prop's not turning 2000. Here it is. But with the gasoline, with the electric motors, that they're all direct drive, and the prop RPM is lower than what it is in gasoline powered engines. This motor turns at a maximum of 2,000 RPMs. When we're cruising, that is in the 13 to 1400 range. When we're climbing, it's up 16 or 1700 range. So there is, even that gives you noticeably less prop noise because that prop is turning less than it is on gasoline powered.
And I was kind of leading to, when you're flying this airplane, you get used to a certain sound as far as RPM in the engine, and when you're getting ready to land, and what level, and then chopping power to flare. Can you get that same kind of? Is it analogous to that with the electric system?
It is, but you're listening to the prop, not the motor.
So the slow speed and takeoff is the exact same.
Can't wait.
The only difference is
Can't wait.
Yeah, it's wonderful. I mean, we've worked on this system for a long time. We had this idea 2 or 3 years ago, and we're so busy it's hard to get these projects moving along. But it really exceeded our expectations, and it looks good, it flies good, it sounds good. I couldn't ask for it to be any better.
So now this electric system, big Tundra tires, and off-road, off-field landings.
Yeah, you could do it for sure. We clean up this as much as we can because drag is the enemy of electric consumption.
Exactly.
So you see, it's got strut bearings, gear leg bearings, wheel pants. All that makes a big difference in longevity of what you can fly.
Exactly.
Yeah.
Less drag.
Less drag, longer fly.
Yeah. Propulsion drag. There are those.
Yep.
Well, Dennis, thank you very much. I appreciate this. You've always, been good with me, allowing me to film things, and I appreciate it.
Well, I'm always happy to talk to you. I always enjoy coming out here to Sun and Fun. We complain for 2 straight weeks about how much work it is to get here, but when we get here, it's a great week to sit around and talk to everybody. For sure.
Thank you, sir.
All right, thank you.
Appreciate it.
All right.
I hope you enjoyed this video. If so, hit the like button. Subscribe if you haven't. And as always, I appreciate your comments. Until next time, take care.